found you!
Hello and welcome everyone to our third Mission Space virtual excursion, Puzzling Physics. My name is Ryan and this is my friend Laura.
And we're from the SciTech Discovery Centre. We're broadcasting to you from Boorloo, Perth.
As such, we would like to respectfully acknowledge the Wadjuk people of the Noongar Nation, the traditional owners of the land that we're broadcasting from.
We'd also like to acknowledge the Aboriginal and Torres Strait Islander peoples from all across Australia and pay our respects to their elders past and present. We'd like to acknowledge them as the first scientists of Australia and value their knowledge as engineers, innovators and problem solvers.
Now you're joining us from all around Australia today, which is super exciting. And we're going to be bringing you away from your classroom lessons briefly through the screen to here at SciTech.
It's really exciting. And we have got a map where we've got a pin for all of you. Can you find yourself on the map?
Yeah, there's so many of you out there today, which we love to see. And as such, we've got some helpers behind the scenes helping us to change the camera, change the special effects, and to activate the live chat. So if you can get on the live chat, please get involved.
We've got so much to show you today. We've got more science demonstrations, more planetarium tours, more expert interviews, and even more. And we're really hoping we can show you how what you're learning at home or at school can help you decode the universe and launch you amongst the stars.
Yeah, so today's topic is physics, okay? So chances are you might have already done some physics at school, whether you're looking at energy or radio waves or how things push and pull and all that. But how does that affect space? So humans have a lot more to learn. We're learning things about space junks and satellites and so on.
Yeah, well, to start things off, we've got something a bit fun. Roll the tape.
We've driven our SciTech truck out to the Gravity Discovery Centre in beautiful Gingin, Western Australia. We already know lots about physics because humans have done some really cool experiments. Space experts seem really worried about tiny pieces of space junk. We haven't got any space junk, but we do have a small compact camera. Let's see what happens when we drop it 45 metres.
3, 2, 1.
This week, our experiments are surely leaving a dent. Today's focus is on space junk, okay? So little tiny things dropping, much happening. How does physics apply?
Yeah, you know, I was wondering, space junk, lots of the pieces are really, really tiny. So why are we so worried about them?
It's a good question. So science is a process about asking questions, making predictions and doing experiments. So why do you think people are worried about teeny tiny bits of space junk? What do you think?
I don't know.
Well, we've got another video that might help explain that. Check it out.
Whilst travelling in orbit, space junk moves faster than 28,000 kilometres per hour. That would leave a far greater impact. We have chosen an anvil to simulate a bigger impact.
3, 2, 1.
That left a far greater dent than the camera. How about these smaller croquet balls?
3, 2, 1.
Whoa, that was a lot of damage.
Yeah, and these kind of experimenting is how scientists learn new things every day. Now, if you joined us for the last couple of days, you will know that we've got some more clips from our interview with Catherine Bennell-Pegg to share with you. They are Australia's very own astronaut, and they've got some amazing things that they've learned that they'd like to share with you. So check out this video.
Is creativity important for astronauts?
Absolutely. You know, in astronaut training, we actually did photography lessons as a way to understand what's happening on our Earth and communicating the beauty of Earth and its fragility back to people on Earth. Problem solving also requires creativity, thinking broadly and thinking with a bit of courage about solutions that are outside of the box. I'm someone that really loves reading and I love poetry, and I think that often art and creativity are the why to the how that is science and engineering, and they go hand in hand really beautifully. And it's important that we consider all aspects when we look to understand ourselves and our planet and our world and communicate that to others.
Do astronauts get to play sport?
Yeah, so on the space station there's a gym. It's really, really important for astronauts to be fit and healthy. It helps you to perform safely in space and also to recover well after you come back to Earth. Doing a spacewalk is one of the most physically challenging things you can do. You have to move around equipment that's many, many tons sometimes. This holding on to a bar on the outside of the space station to move around is like holding a tennis ball really, really tight. So you need good strength in your arms. And good cardio fitness. So we do about 2 hours in the gym each day on the space station. In astronaut training, we're doing sports every day together, and sport is often something that's really important to astronauts throughout their life and their childhood. Not only is it important for your health physically, but also mentally. When you do sports, it helps your brain to develop and grow. It helps you to absorb new knowledge. So sports and fitness are really important to astronauts. If you ever want to embarrass an astronaut when they come back to Earth, throw them a ball. They're not going to be able to catch very well, because in space, if you throw something, it flies in a straight line, because there's no up or down in 0G. But if you throw it on Earth, it flies in a parabola, like a curve. So your brain adapts to imagine where to put your hand to catch a ball very quickly. So yeah, it's a good way to embarrass an astronaut.
You studied physics in school. Did you pick that subject because you thought it would be useful as an astronaut, or did you think it was going to be fun?
Well, when I grew up, my parents were accountants, but my mother had actually studied physics at university. So I was so lucky that she was able to explain to me a bit about the stars and science, and her passion was really transferred to me. And I remember looking at our bookshelf in our family home, and there was a book called A Brief History of Time by Stephen Hawking. And it's a book that talks about really complicated concepts, but without complicated math. So I was able to read it sometime late junior school, early high school, and it just opened up this whole world of science to me, and that led to me reading a lot of other books and science magazines that were quite physics-based, quite astronomy and astrophysics-based, which is something that appealed to me because I love looking at the stars, right? And so physics for me was a way to learn more about that in the classroom. I also love doing aerobatic flying, and I thought, well, if I could study physics, this is going to help me make better roller coasters in the sky. It was a wonderful way to advance my hobbies. If I understood optics, I could use telescopes in the backyard better as well. And it was a really natural subject for me to pick. I very much enjoyed it.
So you're the director of space technology. What kind of technologies are you working on?
So one example that I think is really exciting is at the Australian Space Agency, we have a program called the Trailblazer Program. And this is sending a rover to the South Polar region of the Moon. And this rover is called Rover, like a kangaroo. And it's a small rover, about 20 kilograms. And it's going to go there and explore regions humans have never been to before. And in that area, there's so many mysteries to unlock. When we learn about the geology of the Moon, we learn about the geology of the Earth, because it's thought that the Moon and the Earth were formed through a collision a very long time ago. And so what we can see on the Moon is like the inside of the Earth, or the early Earth. It's like a museum. That's just one example. So that technology helps us to unlock science. We've had capsules returning to Australia with more to come, carrying new kinds of medicines that you can only make in space, returning to the red dirt of our outback. We've got plants in space experiments that are going to help us with, drought-tolerant farming and vertical farming to help us with food security and scarcity on Earth, as well as how to keep astronauts healthy. And here at the Australian Space Agency, with the Heart of Space in Australia, we coordinate all the civil space activities across the country. So it's a pleasure to be able to help support and further these activities through our programs and the other mechanisms that we have to help grow and look after Australia's interests through space.
Catherine's just so awesome. I can't believe you got to talk to her.
Yeah, she was amazing earlier in the week, and we've loved learning everything that we could possibly hear from her. So some of the stuff that I really liked listening to her in that particular segment was how astronauts make time for creative things and sport, not just all the science. We also have a lot of amazing Australian space projects happening at the moment, including the Rover project, which we spoke about earlier in the week as well. And you, all of you, can combine your passion with STEM subjects and you might actually end up in a space career. It's a very exciting time in Australia at the moment.
Yeah, it was really cool to see how astronauts actually do a lot of stuff just for fun. Maybe you can have a think. What would you do for fun in space?
Ooh, what would I do? Maybe space basketball? We'll put that question in the chat and you can enter some of your ideas of what you'd like to do for fun. Now we've got another astronaut, Dottie Metcalf Lindenberger, transmitting from the USA. They are a retired NASA astronaut who also has some more exciting stories to share. They've been in the last couple of videos as well. So stay tuned for the very end of our episode to see their special message for you all. How does he keep doing it?
Don't know, Sog's interrupting again.
Hello again, children. SciTech really needs to up their security on their video feed, don't they?
Sog, you're back again?
Yes, I'm back. You're like listening to me, don't you? Don't you?
I suppose.
Yes. Well, you know the rules. Answer me these questions. 3. You ready? What is the most common element in the universe?
Oh, okay. We got this, guys. It's either hydrogen or nitrogen. If you think it's hydrogen, make a H with your arms. If you think it's nitrogen, make an N with your fingers. Oh, okay. I can see the answer. It's hydrogen.
Oh, how did you know that?
Got some really smart kids here.
Oh, tricky. Very smarty pants. Well, you won't know this one. What's the chemical symbol for sodium on the periodic table?
Oh, I think it's either a capital S and a lowercase d or a capital N with a lowercase a. Oh, if you think it's SD, put your hands on your head. If you think it's NA, put your hands on your hips. Oh, okay, I've got the answer. It's NA.
Oh, NA, not applicable. Oh. Okay, well, question number three. You know the rules. What material might you find on a spacecraft to help it reflect light?
Ooh, to reflect light. Well, it might be black fabric, or it might be gold. If you think it's black fabric, tuck your head away in your arms like this. If you think it's gold, spread your arms out wide like a star. Oh, okay. Yep, okay, I can see the answer. It's gold!
Oh, you really are some pretty smart children, I'll give you that. I will be back.
We did it, guys!
Well, at least they're good questions.
Yeah, they're actually pretty fun.
Yeah, well, curiosity can lead to lots of learnings. And someone who's done that is our space expert, Nat Shearer from the Australian Space Agency, who would like to share some of their learnings with you all. Oh, hi, Nat.
Hey, good to see you here.
Good to see you. Thanks for joining our interview.
Thank you. Thanks for having me.
Have you always wanted to work on space projects?
Yeah, so I probably in uni was really when my passion for space emerged. There's a mission called the GRACE mission where they sent 2 satellites and shone a laser between them, measuring the distance. And it was this amazing mission to measure Earth's gravitational field. And that really sort of inspired me to what can be achieved in such a unique and amazing environment such as space.
And have you always worked in space, or have you done other things along your journey?
I haven't always worked in space. So when I graduated uni, I first went to work in maritime, so worked on Navy ships. Then I worked in civil security, so building security systems, and then worked in underwater, so submarines. And I found it really useful exploring those different domains and learning a lot.
I bet you would have worked with lots of different people from different backgrounds.
Yeah, definitely. It's one of the really cool things about space in particular, where there's people from so many different backgrounds and so many different disciplines, educational disciplines, that it really becomes a melting pot. And, you know, those people are fantastic to learn from and bring different perspectives as we all try and solve the world's problems together.
Now, I heard that you have a pilot's license.
Yes, I do.
Do you get one if I want to work in space?
So thankfully you don't. I was an Air Force cadet when I was in high school, and through that learned to fly. I was very lucky to learn how to fly. But it does highlight that you can learn so much from your hobbies and your other activities, just if you remain open to exploring those things.
So what kind of things can students do now if they want to work in space one day?
Yeah, there's all sorts of things that students can do. There's a lot of STEM activities that you can get involved with through high school and through university. And then you can always just do stuff in your spare time.
Can any of the things that you're working on be used to understand life on Earth here?
So space is such a unique environment that it's unlike anything we can replicate on Earth. Having the microgravity, having the vacuums, it really leads us to be able to understand the fundamental forces of the universe.
I hear a lot about astronauts, but you are someone who keeps them safe. What kind of work are you doing at the moment?
Yeah, so I work in a field called space traffic management. So there's a lot of satellites up there and they're constantly whizzing around and often get quite close to each other. And so we need to understand what's up there, what's it doing, and is there any risk of them colliding? And so we work from the ground to manage what's going on with the space assets.
Is there a particular tool or piece of equipment that you use to communicate between these things?
Yeah, so a lot of it is simulation and modeling. We use telescopes to know where the satellites are. And then there's also a really cool development program called a laser broom, which is a big laser that you shine the laser at the satellite and it puts a bit of pressure on it so it can actually change the orbit of the satellite using a laser from the ground.
Could that kind of technology help prevent meteor impacts too?
Unfortunately, meteors are a bit big and a bit fast, but it does help with space debris. And so it can be used to take space debris out of low Earth orbit and clean up that environment so we can safely operate satellites and put more satellites up.
Wow, that was so amazing. Nat's working with the Australian Space Agency on some of the projects that we were actually talking about earlier in the week.
Yeah, it's really interesting to see how they can apply all the research they're doing to further space research, creating things like new technologies.
Yeah, and speaking of technology, I think Evan has some more technology to show us in the lab.
Hello, friends and fans. Welcome to the Science Theatre. My name is Evan, and... Wait, can you see me? It's a bit dark in here. Let's get some light. Today, we're going to be using fire to explore how we stop heat from moving if we want to protect something that's dealing with extreme temperatures, like a spacecraft. Now, first things first. Is this flame hot? I mean, probably. Feels hot to me. But you can't see the heat, can you? Well, what if you could? Because thanks to our fancy infrared camera, you should be able to see the heat coming off this flame and off everything else in this room. Things which are warmer are going to be white or red, moving through yellow, green, and blue to cooler objects. As you can see, this flame is extremely hot. If I were to put my hand in it, I would get burned very, very badly. However, there are a bunch of really cool things we can use to protect ourselves or objects we care about from extreme heat such as this. Do any of you know any ways we can protect things from extreme heat? If you've got any suggestions, put them in the chat. But for the moment, I'm going to show you my favorite way of protecting stuff from extreme heat. This thing right over here. This sheet here is made of a substance which is incredibly good at preventing heat from moving through it. And I'm going to demonstrate it with two of my favorite things in the world. This blowtorch, and my friend Tony. Would you come out on stage, please, Tony? Thank you very much. Now, Tony is going to be ever so good, and he's going to wait until I heat up this side here with the blowtorch, and then he's going to touch the other side with his least preferred hand. So, let's see how hot this gets. You can see on that infrared camera, it is getting very, very hot, but of course, you don't have to believe your eyes. I have a thermometer here and I can tell you that it is exactly what's that, 300-ish degrees on that bit right there. So, Tony is going to do his very best to touch exactly that part of the screen. Off you go, Tony. Are you touching it? I am. Interesting. I'm just going to turn it around a little bit so you can see that Tony's hand is on there, but it's in fact quite cool on the side that he is touching. Incredible stuff. Tony, thank you very much for putting yourself at risk for the purposes of science and entertainment. I appreciate you very much. Now, you can see that this screen is still very, very hot. The heat is spreading all throughout here, but thanks to the insulating properties of this material, Tony is mostly unharmed, which is what we like to see. This material is an incredibly good insulator. It's very, very good at protecting things from the transfer of heat. And that's very important when you look at the engineering of things like spacecraft. Spacecraft have to deal with the incredibly cold temperatures of space. Space is about 2.7 Kelvin, which is about negative 450 Celsius. It's really cold. And people are going to be in a spacecraft. We need to make sure that the warmth that's needed to keep them alive and healthy and ideally happy is also kept inside that spacecraft. Not only that, when a spacecraft re-enters the Earth's atmosphere, it's traveling so fast that it reaches several thousand degrees Celsius on the outside. And you need to make very, very sure your spacecraft is made of materials resilient enough to keep the insides the right temperature while the outsides are incredibly hot or incredibly cold. Now, this might seem complicated, but you know what? With the right understanding of science, technology, and the right approach to this, you'll find that there's very, very little about space that we can't handle.
Whoa, did he just set his hand on fire?
I think so. I really liked that bit, and also liked how you could use the infrared camera to see the heat, even in a dark room. That was pretty cool.
Yeah, and how he used that pyrogel to protect Tony from the heat of the fire, even though he couldn't see that.
Yeah, that was interesting. I just thought of a nice, fun, easy experiment that you could do. Similar to that, don't use hot water, but if you had cold water in a cup, why don't you try wrapping it in something like paper or foil or a woolen scarf and see which protects it from the cold. It protects you from the cold as you try to touch it. What do you think? This might be an easy one. Yeah, it's probably going to be the woolen scarf.
Yeah, so things like woolen scarf or even things like bubble wrap, they're called insulators because they prevent the heat from traveling through. Maybe we could put another challenge in the chat.
That's a good idea. And other people are doing experiments like this all the time. And there's a whole group of people creating new technologies based on very simple experiments like what we've just suggested.
Yeah, we have another expert with us, Catherine Grace from the Australian Space Agency. She's got some really awesome tech stuff to talk to us about.
Oh, hey, Catherine.
Oh, hey, Ryan. Great to see ya.
Great to see you. You're the director of space. Does that mean you make all the decisions?
No one in life makes all the decisions for everything. My new job right now is the Director of Civil Space Policy for the Australian Space Agency. And that means I get to talk about policy and thought for all of Australia. Before that, I was the Director Space for South Australia. And one of the projects I got to lead was the state making its own satellite and having that launch into space. So that satellite is looping over us now and taking pictures down at Australia.
You would have had to work with quite a few different people before setting up something like a satellite.
We got to work with computer scientists, satellite designers, rocket scientists, so many interesting people doing so many interesting things using space.
Any other occupations that come to mind? Anything interesting that I wouldn't expect to be working with in space?
And this is what I love to tell people. There is a place in space for everyone. So we need to be engaged with and work really closely with science communicators, illustrators, designers, authors. We need to work with people who understand law and legal policy, even other space agencies. And this is probably the most important thing about space. do space. Not just because it's cool and it's fantastic, but because all of that thinking and all of that work actually benefits us here on Earth every day.
So have you always wanted to work in the space industry?
I'm actually a medical doctor.
Medical job?
Yes, my last job was working with blood and blood cancer, so I used to see people who were really, really sick. How does somebody be a doctor and go from that to working in space? I used to think space wasn't for me. My favorite thing about space was sci-fi, but I thought, no way I can have a job in space. The only job I knew about was an astronaut, but I knew what a doctor was, I knew what a fashion designer was, but I knew most of all that I liked to know the answer. So, okay, well, if people are getting sick, what can we do to help them? And I found out space had some really good answers on how to help them.
Have you been a part of any medical research in space?
So I know two brilliant female scientists and researchers, Tiffany and Katerina, who have had microgravity experiments go into space. Now, a lot of people think there's no gravity in space. Is that right?
I hear the word microgravity.
That's correct. Yes. So there is microgravity. So that means that the way things come together is slightly different than it does on Earth. And because of that difference, when it comes to drugs and medicines and crystals, instead of crushing each other like this, microgravity means that pieces can sort of slot together. And with that in mind, drug and medications have really specific targeted outcomes. How exciting and how fulfilling and how good must it feel to be like, you know what? We learned about how to have a good knee in space.
Would you like to visit space yourself?
You know, Ryan, that's a really great question. And it's something that always comes up. And so I'll answer in two ways. One, if anyone ever gives you the opportunity to genuinely go to space, of course, right? It's a really special opportunity and something we should enjoy and endeavor if you're focused on making the world a better place. So space shouldn't be about just launching rockets, sending things up because you want to. It's what are you doing to make humanity better? That's what really matters, because we're in this together to support a great world. I may not be in space, but I know that I've had the ability to work on something that is in space now. There's a satellite that is taking pictures, that is helping Australians understand what is going on with their coastlines, how we keep that healthy and safe with climate change, to have good oceans for all of us. I'm part of something that's in space and it's taking pictures and it's helping scientists understand what heat map is. So when we've got the effects of bushfire, we know how to be prepared, we know how to be safe, but we know how to help our environment heal and go better. Space isn't about being up there. Space isn't about, oh, it's so cool. You know what's so cool about space is that everybody's mind contributes to it. So let's imagine you really like creative writing and you really like video games. Did you know that those people have studied science? They figured out important parts of that space and have created fiction. But it's that fiction that has inspired scientists to be able to think about how to do things. So there's literally a place for everyone in this space.
Thank you for the interview, Catherine. I had a great time.
Me too. See you again.
I've been loving learning as much as I can from all these space professionals out there. There's so much we can learn.
Yeah, and you know, we've been learning so much, but there was actually something that came up the other day. Some of you might have heard of it before as well. The SKA, the Square Kilometre Array. This is a huge project happening in Australia at the moment where they're building a telescope in WA, in Murchison, which is kind of near Geraldton, and it's going to be the most powerful telescope in the world. It might help us learn more about the origins of the universe or things like dark matter and where it is and where it comes from.
It sounds like a really big project. And in fact, they're communicating not just inside Australia, but they're communicating with professionals in South Africa, the United Kingdom, and more. It's a huge project. And I heard they're collecting images using radio waves. Wow. Physics is just incredible that they can enable us to do such amazing things.
Zog's back again.
You know what to do.
Greetings again, children, my little smarty pads. I'm back. My friends left me here on Mars, and now I've got no one to ask questions of.
Oh, well, I guess lucky we're here then, Zog.
Yes.
Come on then, bring it on.
Yes, well, this one should be a good test. You know the rules. Me, question 3. What is the name of the process where something turns from a liquid to a gas?
Alright, this one, it's either freezing or boiling. If you think it's freezing, shiver like you're really cold. If you think it's boiling, give yourself a bit of a fan like it's really hot. Okay, I can see you've got the answer. The answer to the question is boiling. It's really hot.
Do you know everything?
I've got some really smart friends with me here.
Oh, I don't really have many friends. Okay. So, I've seen sometimes, at night, comets have tails. And sometimes they don't. Where do the tails come from? I'll give you 2 answers. One of them, particles follow them due to gravity. Okay? Or, the heat from the sun creates a nice trail off the back.
Ooh, okay. If you think particles follow comets, put 2 fists together like this. If you think the heat from the sun makes a trail for the comet, do little star hands like this. Okay, let's have a look. Oh, yeah, you guys are pretty good. The answer is the heat from the sun.
Oh, I thought that was a really tricky one.
Well, as comets get closer to the sun, the heat actually makes the rock sublimate. That means it turns straight from rock into a gas.
I didn't even know that.
We've got some pretty smart kids with us here.
Oh, okay, maybe I should have done my research. Well, next one, last one. How does the sun produce its heat and light?
Okay, I think it's either burning or fusion. If you think it's burning, put one arm out in front of you and make it like there's a big fire. If you think it's fusion, bring your 2 hands together like this. Oh, okay, I've got the answer. That would be because of fusion.
You're right. I'm gonna need to work on my questions. I think I can make them more difficult. I'll be back.
Good job, everyone. You know, I think Zog might just be a little bit lonely.
Yeah, I think you might be right. They have a lot of spare time on their hands, but at least it's a good way to spend your spare time.
Yeah, and his questions are definitely helping us to decode the universe.
Yeah, we've got some more professionals who've been asking lots of questions and helping to decode the universe. In fact, our next guest is also from the Australian Space Agency, Aniket Jagdep. So I'm going to go talk to them right now.
Hi, Aniket.
Hey, how are you? Good, thanks yourselves.
Doing well, thank you. Thanks for joining for the interview.
Thank you.
So, what does a space engineer actually do?
In simple words, we build cool stuff. We build rockets, we build satellites, we build vehicles that will go on to Moon or Mars. We make sure they run over there smoothly, softly. They communicate with us and things like that.
Fantastic. Is there anything that comes to mind when you say cool stuff? Is there anything that you've worked on?
So right now I'm working on a rover that's going to go on Moon by the end of this decade, and it will be trying to do some really nice science stuff. It will try to see what sort of gases are there around when it lands, just to check out how the soil looks like. Yeah.
So, the rover. So that's quite a big project. You must be working with lots of different people, is that right?
Yeah. So my role is as a systems engineer. What a systems engineer does is he will take all different systems that will go on to any vehicle. For an example, you take a rover. It will have a mechanical design, like it will have wheels, it will have the chassis. Then you will have some circuits and things. You will have electronics, you will have communications. So you have to bring all together these systems to build a rover. So my part is to make sure all these integral things getting together pretty well. Yeah.
Fantastic. Now that sounds like a lot of complicated science stuff.
Did you have to study science at school?
Yeah, definitely. So if you really want to have a career in space, or maybe as an engineer, not in space, space is for everyone. That's what I would like to tell. Space is for everyone, not just for engineers or scientists. But the thing is, if you want to become a space engineer, definitely you will have to study subjects like maths, science, because these are the basic aspects that you will need to work as an engineer on projects like these, or maybe to build rockets and whatnot.
So, is this your dream job?
Okay, I need to confess something. So my dream job was always to go into defense forces, because I always wanted to work on fighter jets or the defense stuff. So that's why I went on and studied aerospace engineering. But my career took a surprising turn, which was really good. And now I work into Australian Space Agency as a systems engineer, which is nothing short of a dream, to be honest, because you're building something that will be on the moon. How many people get that chance to work on?
Now, if there was a young student who wants to follow a similar path and study, go to university, join the space industry, can they do it? Where do they do it?
No, absolutely. I reckon one of the things that I have realized is, like, I have been an average in like academics. That didn't stop me from becoming an aerospace engineer. You don't have to be an expert sort of things, or you don't have to be academically very high. But one thing I would like to stress upon is your persistence and your resilience. You have to be persistent at something. You have to have that curiosity to know how things work, how you are going to proceed to solve a problem. An engineer is a problem solver. So I reckon if as a kid, you can take a toy, you try to deconstruct it, learn something from it. Maybe you might not be able to construct it like how I struggle. I was never able to reconstruct the toys which I deconstructed during childhood. But that sort of curiosity meant I wanted to be an engineer. And yeah, that's what I'm here today.
What sort of things can a student do now?
How are you? Good, thanks yourself.
Yeah.
Particularly, I would say if you're in school, maths and science subjects, those are the basics, as I said before. Those are the basics for any sort of engineering or any other career. If you're in your bachelor's or something, or you are in your college years, you would definitely like to go for PCM, that what we call like physics, chemistry, maths. If you're interested to become a scientist, then go for biology, because you might need it to study a few other things. And if you're a university bachelor graduate or something, then you would like to go for any sort of engineering, considering there are so many different systems in any complex space projects. Like, all of these engineers play a vital part in it.
Thank you for the interview, Aniket.
Thank you.
Appreciated it. So we'll catch you later.
See ya.
Cool. And we're back. I've been loving talking to Aniket, Catherine, Nat, and how all the technology that they're helping to develop can further our space research.
Yeah, there's so much that we can learn, especially if you figure it out using physics. I reckon some of our viewers might have already a bit of an understanding of some of the puzzling physics in our world and how it helps us out in space.
Yeah, so in school you might be doing like push and pull and light, and we've spoken about how that might apply to satellites and space junks and all those kind of things as well.
Yeah, all this talk about space just makes me want to go stargazing.
That's a great idea. Oh yeah, we've got Leon ready with another planetarium show for you all, just in the other room. So hey, Leon.
Hello everybody, my name is Leon and welcome to the SciTech Planetarium. Today we are exploring the mystery of puzzling physics. Imagine you are 10,000 kilometers tall. Here you are. Try throwing a baseball. If you throw it too slow, it falls back to Earth pretty quickly. If you try throwing it harder, it will still fall back to Earth. But because of our planet's round shape, the surface of the Earth curves away from the ball, so it travels further before it hits the ground. Throw the ball hard enough and it will go all the way around and never hit the ground. And this is what we call an orbit, and it's how astronauts stay in space. Astronauts in space live on the International Space Station. It's not very high above the ground, only 450 kilometers up. If you've ever travelled to another country, you've travelled further than it takes to get to space. But the important thing is the International Space Station moves fast, 7 kilometers per second. This is the speed you need to throw a baseball or a space station so that it goes around the Earth without hitting the ground. Because the International Space Station is travelling so fast, the Earth curves away from it before it hits the ground, just like with the baseball we were talking about earlier. The cool thing about being in space is there is no friction to slow you down. On Earth, when you stop pedaling your bike, you'll eventually roll to a stop because the friction from the wheels and the wind slows you down. In space, there is no wind, there's no wheels or anything else to slow you down, so you keep moving forever. And this is why satellites can stay in space for a long time. All of this complicated science was figured out by a clever scientist called Isaac Newton. You might have heard of him. Here is NASA's Voyager 2 spacecraft. It blasted off from Earth in 1977, and that's a long time before you or I were born. It flew to Jupiter, Saturn, Uranus, and Neptune. But because there's no friction in space to slow it down, it's still going. It's still moving. It's 21 billion kilometers away from us right now and getting further away every day. From out here, the solar system just looks like a tiny little speck. It's so far away that it takes an entire day for our messages to travel across space to reach it. Voyager 2 will keep moving through space until the very end of the universe. Gravity from the other stars will nudge it sideways occasionally, but Voyager 2 belongs to the universe now.
Thanks, Leon. That was fantastic.
Yeah, there's so much more we can discover about the universe.
And we will have more for you tomorrow. But first, let's look back at what we did today. So we had another Catherine segment of our interview, which was great to see. Always love learning from Catherine. And we had Aniket, Nat, and another Catherine from the Australian Space Agency. We looked at how people are worried about things like space junk, and we looked about how we can overcome radiation with technology and more.
Yeah, and of course, we were challenged by Zog the alien.
Of course, of course. I'm starting to warm up to Zog. But the main takeaway I'm going to take from this episode is that science and space is for everyone. Curious minds of all kinds can follow their passion and find a role in the space industry, not just astronauts. Build on the stuff that you learn at school. You can make a discovery in space that might also just benefit life here on Earth.
Thank you so much for joining us today. We hope you've had a bit of fun, and hopefully you can join us again for our last session tomorrow.
Before we say our final goodbyes, we have got our transmission from Dottie Metcalf-Lindenberger, retired NASA astronaut who's got some amazing things to share with you. I'm going to set that up just now.
Enjoy. Thanks for coming, everyone. We'll see you later. Bye.
Hello, hi, I'm Dottie Metcalf-Lindenberger. I'm a retired NASA astronaut. I flew to space before you were born. I flew in April of 2010 on a space shuttle to the International Space Station that continues to grow and do amazing things. It surprised me how much it was like a swimming pool, except without the water part. And so the floating came easy because I had this background of being a swimmer in high school, and then also because we do so much work with the Neutral Buoyancy Laboratory as astronauts. But when I got to space, I was like, oh wow, the water really does prepare us, except for water provides drag and air does not have the same drag. And so we look a little funny in the beginning when we're in space because we might be trying to slow ourselves down like we would in the water with, different strokes or different mechanisms. But really, it just makes us look like funny chickens. I became an aquanaut in June of 2012. An aquanaut is someone that goes and lives underwater, and then their work also helps us think about the future of spaceflight. I lived underwater for 12 days at the Aquarius Reef Habitat. It's 65 feet below the surface of the water. And we live inside of something that looks like a submarine, except for unlike a submarine, it's tethered to the bottom or connected to the bottom of the ocean floor. And we leave a hatch open because the inside is overpressurized. So we can come and go in scuba gear or in diving gear. And then we pretend like we were doing spacewalks. And specifically, my crew was pretending like we were doing a spacewalk at an asteroid, a near-Earth asteroid, one that we might consider sampling to help us understand about the formation of our solar system, about the resources of asteroids, and maybe even do we want to mine asteroids? So these were some of the things that we were looking at as aquanauts. But an aquanaut is just someone who lives underwater instead of in space like an astronaut. So I just want to say I hope that you are always curious about space, but no matter what, I hope that you work hard in your classes and learn lots about Earth and space, because I hope I've showed you today that they're really together. Like, we are on a spaceship, and that spaceship is our Earth, and that we have to take care of it. And by understanding Earth, we can understand more about space, and then space can also help us understand about Earth. So be curious about it, keep working hard and challenge yourself in your classrooms, and have the courage to go after your big dreams like I did with being an astronaut.
See you all soon.